Okay, today we're going to do our first set of notes, and it's right triangle trig with the Pythagorean theorem. So we need to know how to use the Pythagorean theorem before we go on into kind of introducing trig. So you've probably done this before, but we'll kind of review. A right triangle or Pythagorean theorem can only be used with right triangles. And what makes something a right triangle is if it has a 90-degree angle in it. When we look at the sides of a right triangle, the side opposite the 90 degree is our hypotenuse, and the other two sides are called legs. And then we use a squared plus b squared equals c squared as our formula. So that means if we take one leg and square it plus the other leg squared, it should be equal to the hypotenuse squared. So we're going to use this to help us find sides of a triangle. So we're given two sides of the triangle and we have to find the third side. You always want to leave your answer in simplified radical form. Don't use decimals. So the first thing we want to notice is that this is our right angle. So the side opposite is our hypotenuse. So this is my C. So this is my hypotenuse. So the other two sides I can call A and B. It doesn't matter which I call A and B. And then we'll use this formula a squared plus b squared equals c squared. So it's going to be 6 squared plus 8 squared equals c squared, and we just do the math here. 6 squared is 36, 8 squared is 64, and we're looking for c squared. So I'm going to get 100 equals c squared. Take the square root of both sides. And this is nice because 100 is a perfect square. You can put that into your calculator, or you can recognize that this is really just 10 times 10. So the square root of 100 is 10. So that means our hypotenuse, or the missing side of the triangle, is really just 10. On the second example now we have not the hypotenuse that is missing, but one of the legs is missing. So our hypotenuse is opposite the right angle. So that's going to be the 12 centimeters. So this is our C. And then we can call 4 meters A and the X, the unknown side, is B. We could switch those A and B, it wouldn't matter. So we're going to use a squared plus b squared equals c squared. So 4 squared plus x squared equals 12 squared. I'm going to get 16 plus x squared equals 144. We're trying to solve for x, so I'll subtract 16 from both sides. So I get x squared is equal to 128. Take the square root of both sides, and I end up with x is equal to square root of 128. So now we need to simplify our radical. We don't want to leave our radical. We don't want to leave this as a radical that can be simplified, so we got to remember to simplify this. So I'm just going to go through and I'm going to simplify by doing a factor tree. So 2 goes into 128 64 times. 64 can be broken down to 8 and 8. So we're looking for pairs. Here's my pair. Because it's the square root, we're looking for pairs. I'll take an 8 out of the radical and I will leave a 2 under the radical. So this will simplify down to x is equal to, take out an 8, leave a 2 under the radical. So that means one of my legs will be equal to 8 radical 2. My last one here, now the only thing different here is that we have radicals as part of the lengths of our side, but we'll do the same thing. We'll look for the hypotenuse. I always like to decide where the hypotenuse is. Here's my right angle, so my hypotenuse is opposite of that. So that is my C value. I can call this XA and radical 3B. Those are my legs. X squared plus, or A squared plus B squared equals C squared. Go ahead and plug in. I'm going to get X squared plus radical 3 squared equals 2 radical 3 squared. I end up with, when I simplify this, this is X squared. Radical 3 squared is really radical 3 times radical 3, which gives me radical 9. 2 radical 3 squared gives me 4 radical 9. So this ends up being x squared plus 3 equals 4 times 3. X squared plus 3 equals 12. Subtract 3 from both sides, and I get x squared is equal to 9. Take the square root of both sides, and that leaves me with x is equal to 3. So the unknown side is x is equal to 3. If this is confusing up here, you can look and see that this is really radical 3 times radical 3. This is really 2 radical 3 times 2 radical 3. If you have any questions, let me know. I'll be available by email. Thank you.